Hello. Hello and welcome to a tutorial on OpenCV in Python with a bit of an overview of computer vision in general. This is a fourth tutorial in the series of Python tutorials within the series of tutorials on the introduction to software and robotics. In this, obviously, computer vision is a huge topic in robotics and of course more broadly as well. And this video, like the other videos in this series, are meant to simply give you a taste of what's possible and empower you to find more for yourself. But essentially just introduce the terms so that you know what to Google. Okay, so in this video we'll do the following. We will give a hello world equivalent in OpenCV in Python. So starting up a stream on a camera and doing some operations on it. Then we'll have an overview of classic computer vision in action. So classic computer vision here meaning that you design how to extract information from an image. It's not, there's no learning happening. You sort of pre-program all the knowledge that you give to the algorithm. Then finally, we'll just give some example resources on deep learning based computer vision. So, using CNNs for various different things. There will also be a small example of how you would go about training a model, a particular model, and then sort of use it in OpenCV in that pipeline, basically. But we'll also mention some bit more relevant packages that maybe are of most use in the context of robotics. Okay, with this introduction out of the way, we can start on the Hello World equivalent. Okay, so let's run the most basic program to simply open up a video stream. This is on my laptop camera that I've been using in OBS as well. And before I switched to OBS, I would simply have this thing on screen and record the raw FFmpeg. Now the way this works is you just if you want to use your laptop camera, you gotta give it 0 here. I'll go over the code a bit shortly, but just for fun, I want to give a bit of some more Linux information, of course. So in the dev folder, /dev folder, you have a bunch of these different devices, and one of them is called video 0. And this is where your camera lives. And in fact, if you have a video player, you can just start playing this file. Maybe I would prefer it this way. Yeah, there we go. And now I'm in a video player, and this is super laggy. But I do find it very interesting that you can, everything is a file, including your camera. Okay, now let's get back to the script. Here we go. This is this little script. This class handles all kinds of different inputs. You could give it a file name that it would start playing a video locally from your computer, or you could even give it a stream. And well, this is what I'll show you in just a second, but let's first go over this very small loop. So you call this video capture objects function to read. It will spit out something in the frame. With this frame you can do, well, the frame is just an array of numbers. It's a picture, but the picture in the computer sense, where if it's an RGB picture, image, then you have tensor where it has a matrix of height and width of the number of pixels, and then 3 of those for every color channel. So it's like 3 matrices in one sort of linear operator, basically, linear operator space. Yeah, there's a bunch of, so I mean, you can just do whatever math you want on this. It's just it's a tensor like any other, with, I mean, specific meanings of what these numbers are. But anyway, you have a bunch of different CV pre-made operations, like I used flip here. You can use a different scale to make it larger or bigger. And okay, so I'm resizing it here, even though the scale doesn't change in this particular example. And then we do the image show, so that that's what shows up the image. Now, well, the reason why we have to really have to go over this file, because this is not obvious at all, and I did spend a number of hours before I realized this for the first time. You need to have this wait key for the smallest possible amount of time here. Basically, if this is a 0, then it waits forever by convention. Yeah, you need to have this wait key command in order for the stream to actually run. Otherwise, it freezes on a single image or holds it for a number of, I think, milliseconds it is. That's defined here. Waits for a pressed key. If it's 0, waits infinitely. Otherwise, for the delay of some number of milliseconds. All right, and it can wait more, as you saw, lagging when I use this for video production. And yeah, I mean, it catches some key, and if you turn this key that's not a string by default with this odd thing, it will, yeah, it will, or rather you turn the string Q into the type of this key press, then you can get something. So while the stream is running, you can do something with these key presses to control it a bit. I have an example of why this would be useful, but anyway, that's it. Let's do a basic transformation on the... since now I'm running OBS, it's taking control of my camera, so I can't run this at the moment. Well, not this video capture at least. So let's actually skip ahead and open a video capture from a stream. You might be asking yourself what kind of a stream this is, and it will be a stream from my smartphone, which is an Android phone. I'm pretty sure that applications for this exist on other systems as well. Anyway, I have this application called IP webcam. I click on this IP webcam thing, I scroll all the way down, and I want to click on this button called Start Server. And yes, it does have commercials inside. Okay, now it started up a camera. Yeah, I don't want to show the back of my room, but what's of interest, it is showing things. Okay, in the bottom you have the IP address of the server. Now your phone and your laptop need to be on the same LAN for this to work, and on EduRoam it won't work by default. Anyway, what I want to do with this is I'll just type the IP that you were probably able to see down below. 1.6, 1.8, 80, 80. And now I have, with a whole bunch of lag, this, yeah, now you can see my setup from here. Let's do the infinite thing. Hell yes. Okay, and yeah, but who cares about the web interface? We're here for the OpenCV. And now if I, okay, this got left over. There we go. Now if I put the IP address, the same IP address, 1.6.80.80, and the slash video. In the I didn't show this, but where was it? That's it. If I go to slash video here, it will go directly to the stream. It won't give this like HTML thing. Okay. So that's what we want. The OpenCV can't understand this web page thing. So let's now run programs camera no lag thing. And it's gonna give a very big, there we go. I find this stuff incredibly funny every time it happens, even though I've seen it a million times. Digital mirrors holding each other. Okay, anyway, let's do a transformation now. So frame, and now I'll use something like grayscale. I had this. There we go. I don't know these things by heart, so it's I put in a pre-made function. Let's just verify that it works. Like this. And there you go. Now it's in grayscale. Okay. Now the reason why it's lagging so much is because I'm sending this over my router, and there's a bunch of computers on it doing web things. If you were, the best way to use this with minimum lag would be to provide a hotspot to your laptop. Of course, turn off your data just in case your internet service provider decides that this is somehow using your data because it monitors for whatever reason. Okay, just do it to be safe. And then you can also use a smaller resolution, which you can set in the app. Anyway, let's just look at these commands. So yeah, you have this frame, you pass the frame, and you select a color filter. There's a whole bunch of these different various commands that you can use, and I will of course guide you to the documentation for that, because it's better for you to, I think at that point it's faster for you to read what's out there than to listen to my yapping. Okay, and now yeah, let's see the results that you can achieve with this. So I'll go to an old project I had. There we go. Now I want to put in all of these images like that. Okay, so this is my hand grayscaled. What I wanted to achieve here was to detect the number of fingers that were being held up. I think I did use someone's GitHub repository for an initial point here. Sorry for not giving credit. I mean, it's not, these transformations all kind of do the same thing. Okay, so we apply some dilation here. Okay, we want to apparently window resizing does its own thing automatically. Anyway, we blur it a bit. I don't know if you can see that, but it's now a bit blurred. Why? Because usually you have a bunch of things in the background that you just want to remove, small patches that you can remove with blurring. Now we, I think first you put the image to grayscale, and now you put it to black and white, where this are all, now this is a single color channel. Well, this was a single color channel as well, but it had numbers from 0 to 255. I think, and now it has either 0 or 1. So 1 is white and 0 is black. And now you can do some kind of algorithms for classical computer vision. So you would do something like, okay, for this row, let's go around and see whether there are any differences, any ones basically, from all these zeros. You go like this, say, okay, here I see a little patch that's different. And you keep doing this and keep doing this and keep doing this, and eventually you find where all of the places where the numbers change from 0 to 1, and now you have an outline of this object. that would be used, and then you can delete the inner part, and now you have the edge or the contour of this object, and then you can do some sort of math to find out what kind of a shape it is. Here there's a convex hull that's been found around the hand, and mind you, all of this is black magic. There's no really, scientific way to calculate what a cat is from an image. That's why we use neural networks. But if you have a simple problem, there's no need. You use the right tool for the job. Not if the only thing you have is a hammer, every problem looks like a nail, and the hammer being a convolutional neural network. Anyway, what we do is we take a smaller circle, and then you do the edge detection there, and now you know that like these things right here should be fingers basically, and this would be a thumb, let's say. Again, it's very black magic of how you get to this, because there's no real modeling here. So that would be sort of like an example of what you can do with classic computer vision. Before we get to the deep learning part, I forgot that to sort of say that how powerful classical computer vision can be. In this particular video, one of the researchers, the principal robotics system engineer, Andrew Johnson, is talking about the system that helped the Perseverance rover land on Mars. And in their image processing stack is classical computer vision. Now, I definitely encourage you to watch the video. It's in many ways, space exploration is sort of the peak of engineering. At least for me, it's one of them, and it sort of comprises the most impressive. Only the best of the best things do we put, and the most tested and most reliable do we put on spacecraft. And yes, with classical computer vision, you can land on Mars, literally. So, despite it being a bit of black magic-y and hacky, you can do amazing things with it. Okay, so far we've covered something in classical computer vision. Before I tell you sort of where to look for more of that, I do want to also first talk a bit about how you would go about using a deep learning kind of stack. Now, I'm going to guide you a bit through where I used it in a project about 3-4 years ago. So ancient technology in the context of AI, but I think you can get something out of this still. So the first thing that you would need to do is to generate a data set. Now, if you're not using a pre-trained model that already works out of the box, I will point you to some of this as well. But typically you do want to train your own model on something. Really, you want to use a pre-trained model to then sort of fine-tune it or have it learn your data set as well. Let's first talk a bit about data generation. So typically, as you probably know, these models require a ton of data, and that's very annoying to find. So you would have if you want detection, you would need to find a picture and then draw a rectangle around the object you want to get one data point. You have an image and you have the bounding box of what you want. If you're doing object detection, we should have said that first, but object detection is the most classic example that you would want in robotics. Alternatively, what you can do is you could generate a data set, sort of auto-label a data set. So I had this in the project that I'm gonna demonstrate soon. The idea was that we find some sort of gestures, and we do a bounding box and detect these gestures to do stuff with it. And in this particular case, you could, instead of having the image, of someone doing this, and then with your mouse finding a bounding box around it, you could instead take the object, your hand, put it something like this, and put it in the bounding box. Now, of course, this won't give you the purest of data sets, but at least, a bunch of the images. And anyway, then we start going around like this, around and at every few, I don't know, some number of points, there's a snapshot being taken in this rectangle. So, I mean, you can have a camera stream, put a bounding box on it, and then go around and take many pictures of the object that you have. And I mean, this was extremely simple in this case because we just wanted to see the hands and then do something with them. But this idea of auto labeling is is key if you yourself want to get a few thousand examples for something to work. And this is the order of what I needed in this project. It was about 2,000 examples per class. Yeah. Okay, so let's see what I did with this. So it's trained now to recognize the different gestures. So if I give it like a 2 or a 3, it's gonna do something with them. And there's a plus. And on the equals, there would be a robotic hand that would produce the, plus something that would produce the result. And then you would give it a thumbs up if it was correct, a thumbs down if it was wrong, and okay, sort of reset it back. Now this is extremely poorly trained because I was 90% of the data set were my hands, but even still, I mean, it does work, as you can see, reasonably well on me, on this particular, on laptop cameras, I suppose, with pretty much nothing going on in the background, but still. This was YOLO V4, and it's there's a binding that integrates it into OpenCV. So you do a video capture to show it previously, and then you load the neural network into some OpenCV class, and then it's very easy to set it up to draw what you want as well. Just have the back. I think the back worked the worst. Okay, anyway, that is that. And now let's I mean, there's no point in showing you the code really if you just look at the any example of loading a YOLO network this would do. So let's keep moving forward. Let's just sort of I just want to bring up what you can find as a sort of ready-made solution. Again, this was a bit old. Okay, so this would be the homepage of Ultralytics, and they continued. They're the best, as far as I know, in the continuous development of YOLO networks, which stand for you only look once. And the idea there is you do all the processing on one frame, and then if this is fast enough, you can do video processing. And then you can track objects, do many different things with this. They have a YOLO 11 at this point, and it's no longer just the object detection with bounding boxes that we saw. It's of course in Python. They have the Ultralytics pip. They offer you the weights so that you can have a pre-trained network, sort of very similar to what I showed before. But I just want to sort of list the tasks. So this would be object detection. There's an MS Coco data set with like 80 different things. That was what YOLO before that I used was trained on. I don't know what they use now. Okay, that's wait. This is what I wanted to click. So you have segmentation as well. When I was doing my masters, this was like very, very crazy and tedious to get. But there's segmentation as well. I'm not sure whether all of this is sort of in one big network and then you just sort of tell it to do different tasks. But I mean, you can find for yourself There's of course classic classification, the most classic task. But what I find really interesting is that you have poses as well. And then you can find a sort of whole human skeleton. So if you're doing some sort of human-robot collaboration or something, this would be particularly interesting. And there's an older project that stopped being updated in 2020, which okay, my internet is a bit slow now. Anyway, where the hands would be detected as well. So this is. I mean, I'm sure that there's work continuing this, but yeah, I mean, out of the box, you can get incredible things if you just scour the web a little bit. And okay, so now you have sort of a flavor overview of what you can do with deep learning computer vision, that it plays a role with, that you still need, you know, classic OpenCV if you want to, for example, auto-label a data set, and very often you know, you want to generate as much example data from the examples you have, so you would then use OpenCV to, you know, flip the image, rotate it, cut it here or there, you know, put in small patches, stuff like this. So knowing transformations and knowing how to do them in OpenCV is still incredibly useful for even, you know, for deep learning training. I don't think it's a good idea to just skip that if you want to know a bit more about if you want to, you know a lot about computer vision, you still need to know all this. Okay, now we're at OpenCV documentation. It's not as good maybe as the Python standard library or NumPy or something like this, but there's still a plethora of tutorials, and I still think it's the go-to resource. I mean, given last time I delved in depth into this was like 3-4 years ago, so they might have changed it a lot. I'm not sure, but yeah, if we click on something like tutorials, then you will find a whole list of different tutorials on this and that, including the DNN module, so that you can you have all the, you know, bookkeeping that you want around a deep neural network. Here in the image processing tutorials, okay, this is way bigger than what I remember it to be. You can find, you know, for every particular kind of operation, a bit of context on what it does. You have, yeah, OpenCV is written in C++, and then has Python bindings, as, you know, these most software in robotics does. I mean, this is not just robotics, but you know, Python, C++ is a classic combination. So even if you find a tutorial that's in C++, chances are that the functions are named, you know, in the exact same way in both languages, and that you can just, you know, use to figure out, you know, what functions exist. You can look at C++ code as well. Okay, so we have dilation and erosion here, and you know, there's I think thresholding and getting the no, sorry, that's for the thresholding is if you want to do colors. Right now, click on something else. This one, yeah. So if you want to filter out the color, that's very common. Then you know, you would go here, and there's a bunch of things that I have, you know, no clue about, but yeah, and you have a whole sort of tutorial on how to use this. This is very good. And of course, there's documentation on specific modules. And there's, of course, the reference for all the classes that exist. So if I were to go to CV, then there's, yeah, a bunch of things out here. So if you know a particular class and you want to get more documentation on what it does or what a function does, then you would, you know, go to this Doxygen generated documentation, which is like sometimes a bit more easier to use than just the getting it in from your Python shell or whatever. Okay, so now you know where to look for more classical computer vision. You have a rough idea of what it takes to do a deep learning type project. Of course, you could do everything from scratch, but this is we're just introducing things here. This is by no means nothing that I've told you about is in depth. I just wanted to point out where you can find the in-depth stuff. And yeah, we also did the hello world example so that you started off your stream, you know how to not freeze your camera when you do that, and now you're good to go to explore more, play around with this. I hope this video was useful to you, and I wish you the best of luck in your computer vision adventures.